So we've done the adding, the subtracting, the multiplying, the dividing. Last part that we have to cover within this unit is solving rational equations. Now again, kind of the nice part about this is everything we've kind of done, especially with the adding and subtracting, it kind of has led it up to this last piece. So if you can add and subtract rational expressions, the equation part just kind of falls in back in there, and now it just becomes solving equations. So we're going to look at solving equations today, two different types. We're going to start out if we have a monomial in the denominator with a question like this, and then we'll look at what happens if we have binomials and trinomials in the denominator as well. So the first one, we're going to solve this rational equation, and obviously what makes it an equation is we've got an equal sign in there now. So just like adding and subtracting, when we did that, like we have on the right-hand side here, you need to have a common denominator. So that's the first thing that we're going to find. And we're actually going to do it pretty much the exact same way as we did it when we were adding and subtracting. We're going to list our common denominator and then go ahead and compare them to what we have, or what the original rational was. So if we look at this, we've got monomials, we've got x, we've got 4. So that makes our common denominator 4x. We've got an x in the first term, we've got a 4 in the second term, we've got an x in the third term. We don't repeat the term, we don't repeat the denominator piece of it. We just write what we have. Now we compare denominators, just like we did when we were adding. We compare the denominators and ask the question, what's different? Or how do I get x to be 4x? Obviously, we just multiply by 4. So 4 times x is 4x, but because I'd multiplied the denominator, I also need to multiply the numerator. So 4 times 1 is simply just, don't erase it, is simply just 4. So 4 over 4x is the same thing as 1 over x. They're equivalent to each other. Now we compare the second one, or the second term, which is 1/4. Now we're going to turn the denominator into 4x. So therefore I need to multiply both of them by x. But when we just kind of look at that numerator, 1 times x is x. Okay. And then we compare the last ones. How do I get x to be 4x? Again, you multiply by 4 again. So then we have this new equation. Now this equation is equivalent to the one up above. Now, keep in mind, obviously, one of the things we worked on the other day was we said, well, if you can reduce, reduce. Well, obviously, we don't want to reduce this because if we reduce it, we're just back to where we originally were. Okay, so now that we have all the denominators the same, we're going to go ahead and perform the operation. So 4 over x, can't really do anything with this, but I've got x plus 8 that I can rewrite this side, the left-hand side, as x plus 8 over 4x. And just combine those terms by adding like we did last Thursday and Friday. Now, we have two essentially fractions that are equal to each other. So one of the things that you were taught a long time ago is you were taught that if you have two fractions that are equal to each other, you can cross multiply. So we can go ahead and take 4 times 4x and make that my left-hand side. I'm getting there. Is it off the board? Okay, and then we can do this, but your answer is yes to that. So that's 4x times x plus 8. Now you could make your life difficult, and you could take 4 times 4x, and don't do this. You could take 4 times 4x and get 16x. You could take 4x times x, get 4x squared plus 32x. You could get that, and you've got this equation. then that you could solve. However, I can also take this and divide by 4x. And if I divide this by 4x, now 4x divided by 4x is just 1. So I'm just left with 4. 4x divided by 4x is 1. And I'm just left with x plus 8. Well, the question that I believe was going to be asked prior to me getting there was, don't you really just have to look at the numerators, right? Because the denominators are the same, they're going to divide out and give you 1. So essentially all you have to do is kind of ignore the denominator and solve the equation that's created by the numerator. Okay? I did this time because I wanted you to see why it works. Now you know it works. So everyone from now on, I'm just going to kind of ignore that denominator, ignore that denominator and just write that equation and then solve. So if I subtract 8 from both sides, I end up with a solution here of x is equal to negative 4. Now here's kind of the thing with this, is you have to check to make sure that it works. Okay, by working, I need to make sure that the solution doesn't create a denominator of 0. Sometimes in these you can get solutions that appear to be solutions, but if you put it back in there, it makes your denominator 0. And if it makes your denominator 0, obviously we can't have that. We talked about the domain. If I asked you for the domain for this, the domain would be all reals, because the domain is always all reals. If I'd set my denominator equal to 0, so my range for this, or my domain for this, I don't know why I said range, the domain for this is all reals, except for x can't be 0. So 0 can't be a solution. Well, I don't have 0 as a solution, so I'm okay. So our solution for this negative 4 is going to be just fine. But you always need to check to make sure that the solution you have is part of the domain. If it's not part of the domain, it can't be a solution. And that's going to happen, where you get something and, man, that doesn't work because it makes that denominator 0. So you always have to check. It's like what's called an extraneous solution. It looks like it's okay, but it's not. Okay? So let's look at another one. Okay. So now let's take one and now put a binomial in the denominator instead of them both just being monomials. So we've got 5 over x is equal to 9 over x plus 8. Again, we'll do it together. There's no really even adding or subtracting done with this one. They're just equal to each other. What's our common denominator? X times x plus 8. Compare the denominators. What do I need to multiply the first one by? X plus 8. So that gives me 5x plus 40. What do I have to multiply this one by? X. 9 times x is 9x. So the equation I have to solve then is 5x plus 40 is equal to 9x. Subtract 5x from both sides. You get 40 equals 4x. X is equal to 10. My domain is all reals, except for x cannot equal 0 or negative 8. And all I did was set that denominator equal to 0. It's not there. 10 isn't one of those, so it's good to go. Could you plug it in and make sure it works? Sure. Are we going to? Questions with that one? Let's take one and make it a little more difficult. So now we've got x over x minus 2 plus x over x minus 3 equals 3 over x squared minus 5x plus 6. What should we do first? Factor. So let's go ahead and factor the x squared minus 5x plus 6. It's a trinomial. So we'll try the x method. So 6 and negative 5. Negative 2 and negative 3. So that factors into x minus 2 and x minus 3, which we already have, which is good. So my common denominator is x minus 2 and x minus 3. Because of how I have this set up, I got to shrink things down here a little bit. That's x minus 2 and x minus 3 equals x minus 2 and x minus 3. So if we look at the first one and we compare their denominators, I've got x plus 2. I need it to be x minus 2, x minus 3. So multiply my numerator by x minus 3. That gives me x squared minus 3x. Ooh, we've got an x squared in there. Compare the second ones. I've got x minus 3. I need x minus 2 and x minus 3. So I need to multiply it by x minus 2, which is x squared minus 2x. Get the third one. It appears to be the same. And all I have to do is put 3. So we can just look at this now. Perform the operation. We've got x squared plus x squared. So it's 2x squared. We've got negative 3x plus negative 2x. That's negative 5x. Equals 3. So far, so good? We've got a quadratic. So that means we have to put it in standard form. So subtract 3. So that's 2x squared minus 5x minus 3 equals 0. We've got a quadratic trinomial, so we can use a quadratic formula, complete the square, or try to factor it. My guess is you want to try to factor it. What goes on the top? Negative 6. What do we have to divide by? Have to divide by 2 because my a value is 2. Denominator, or the number on the bottom, is negative 5. So negative 6 and 1. So if I write that out, that's x minus 3 and 2x plus 1. We have to solve. So what makes that 0? X minus 3 equals 0. X equals 3. 2x plus 1 equals 0. Subtract 1, divide by 2. X equals negative 1/2. Okay, so those appear to be our solutions. But if we look at the domain is all reals, except for x cannot equal 2 or 3. So x can't be 3, but we said it was 3. It can't be 3. So that is not a solution. So your only solution for this one is negative 1/2. And you always have to check for that extraneous solution. What looks like it's going to work but doesn't. And the easiest way to do it is just write the domain down. You've been having to do that anyway. So you might as well continue just to write that down. So the process can get a little bit long, but again, all pieces that we've kind of built in that you can put together at this point. Okay. Any questions with that one? All right, let's look at one more. Actually, you're going to look at two more. Maybe it's one more. We'll see. We'll see how we do. Go ahead, give that a shot. Okay, so I do have some of it done. Check and see how you're doing. A couple more seconds and then I'll finish it from this point. So we're good with the 5x squared minus 20x equals 5x squared minus 15x plus 20. Okay, so at this point, you're kind of at a point where you got to kind of start moving things around, right? And certainly one of the things you could do, you could subtract 5x squared from both sides and add 20x to both sides. But you should be starting to get yourselves to the point where if you notice that you have the same exact thing on opposite sides of the equal sign, they're just going to cancel each other out. Okay, you're going to subtract 5x, you're going to get 0. You're going to subtract 5x squared, you're going to get 0. Okay, so those are going to kind of go away. So then I've got negative 20x equals negative 15x plus 20. Add 15x to both sides. That's negative 5x equals 20. Divide by negative 5. You get a potential solution of x is equal to negative 4. Does it look right? Okay, if we look at the domain for this one, it's all reals. X can't be, set your denominator, x can't be 6 or 1. It's not 6 or 1, it's negative 4, so we're good to go. So that's our solution. X is equal to negative 4. Are we okay? Okay, so the big part of today becomes you're going to build those equations that you have to solve now. You build them by getting that common denominator. Remember, once you've got that common denominator on both sides of the equal sign, that denominator is only now going to be used to help us find those kind of extraneous solutions by finding that domain in there. Okay? Any questions before we get going?